Hello, all REU and RET participants. Our project has to do with smart streetlights. My name is Alberto Radigi, REU participant with Morgan State University.
My name is Shalom Dades, REU participant with Morgan State University.
Hi, everybody. My name is Mr. Dennis Ndati. I'm a RET participant from Morgan State University. Our project mentor is Ms. Hasmat Fatima. Our faculty lead is Dr. Kofi Nyarko.
Thanks. So for the background, we're dealing with two different projects here. A $30 million project, which was to deploy around 3,200 streetlights, which was integrated into the existing shot spotter network so that they could locate where gunshots were coming from, as well as detect other sounds such as broken glass and car crashes, as well as help manage the traffic situation. In the second project, titled Smart Street Lighting System Using IoT, which stands for Internet of Things, the team developed a system with a Raspberry Pi, PIR motion sensor, Pi camera, and LEDs. So this ties into our project goals. We're developing a system that will initiate video recording due to gunshots or heavy motion within the motion sensor's range. So as you can kind of tell from the background, we're basically taking the best of both worlds from those two projects, using the more cost-effective Raspberry Pi and equipping it with different sensors and stuff like that, as well as using the ability to detect gunshots and differentiate between different sounds. So for any gunshot or heavy motion, the video is going to be saved and then sent to a web application for law enforcement access. Furthermore, we'll develop activities and projects using Raspberry Pi so that Mr. Dennis's students can learn how to program using Python and machine learning algorithms. The tools that we need to perform this project are Raspberry Pi, sound sensor, PIR motion sensor, Pi camera, Python programming software so that they can design the program, and machine learning data sets to train and test the models. Other software and tools, Jupyter Notebook for more programming, Anaconda so that we can install and import libraries, GitHub, and Visual Studio Code for collaborations using the LiveShare. So this conceptual diagram, which is actually made by Mr. Dennis himself, details basically the process of us going through the project. We have the Raspberry Pi, which leads to the triggers. So what would happen here is so the camera itself can actually plug into one of the ports here on the Raspberry Pi. Then we have the GPIO port. The GPIO breakout cable would connect into the GPIO breakout board. That board would be hooked up into a breadboard. Then from the breadboard, so we see the different pins here on the motion sound sensor. Using jumper wires, we connect those into the different GPIO ports for power, ground, and also the dedicated outputs. This will lead into our programming portion where we're dealing with 3 30-second video buffers, and also the ability to use machine learning to differentiate between different sounds and using sound analysis. Then should a gunshot be heard, those video files are going to be sent into the cloud for law enforcement access. So the Raspberry Pi, as we mentioned, we're going to equip this with the HD Pi camera for video recording. The sound sensor will pick up sounds of gunshots and other sounds, and then the motion sensor will detect any movements within its range. For Python, again, we're going to be using Python as our programming language so that we can create programs that will allow for us to detect sounds and trigger the recording process if that sound happens to be a gunshot. Thanks.
Okay, thank you, Alberto. So for the continuation of the methodology, we also tried to create a neural network to be able to differentiate between the gunshot and non-gunshot sounds. And we also worked on a circular buffer of 3 30-second video clips in which the oldest clip will be removed each time, and only clips with gunshots and lots of motion are saved. Next. So here we have some video demonstrations of how the sound sensor and the camera are working together as a unit. Let's have it. Okay, so right now what he's trying to do is, you can see he's running his codes and he's clapping his hands. It's expected that the sound sensor will detect the sound and trigger the camera to start recording. So okay, the sound has been detected, and here we have the video which was recorded. So we're able to achieve that. And secondly, we have a demonstration of video about the circular buffer for the video recording, just like we had with the sound sensor. This time around, we're trying to get the motion sensor to trigger the recording process. Let's have it. Okay, so right now he's trying to run the codes, and then okay, so currently just run the codes and it's trying to get some motion around the motion sensor. Yeah, the motion has been detected. So we go back to the folder where we're saving our 30 seconds video clips from our buffer. And yeah, there we have the video recording that has been triggered by the motion sensor. Next. Okay, so here we have some results. The Raspberry Pi system created with camera, motion, and sound sensors. So we're able to assemble our Raspberry Pi with a tight connection between the Raspberry Pi camera, the motion, and the sound sensors. Also, the sound and motion sensors are able to trigger the camera to record videos. Yes, just as we saw in the demonstration videos, we have been able to make the sound and motion sensors to trigger the camera to record videos. Also, the neural network has been assembled and is still we're still working on getting test files to pass through the model so we can predict which sounds are gunshots or not. The buffer was set up where 3 30-second video clips are created, with the oldest clip being removed and replaced by the new 30-second video clip. Next. Yeah, we faced some challenges, which is inevitable. The biggest challenge was getting the neural network to train the model using the audio files from the data set. So we tried to get the neural network to be able to distinguish between the sound of a gunshot and the sound of something similar, like that of fireworks. So we need it to be able to give us accurate results of differentiating the different sounds. Also, we faced some challenges by using the desktop versus using the laptop monitor, importing libraries and dealing with compatibility issues, machine learning algorithms, and the importance of understanding the process. The fact that we're doing the project virtually, some people were using desktop, some people were using their laptops. So we were having little compatibility issues, but we're able to sort that out in good time. So it wasn't such a big hindrance to the project. Next.
Well, thank you very much, Shalom. So now we're going to look at how we can apply some of the skills we learned throughout this project in a high school classroom. One of the classes that I teach is digital electronics class. One of the units in that class is called microcontrollers, microcomputers, and microprocessors. We've been using Arduino as a platform. this is where I want to introduce the Raspberry Pi so that students can learn how to program. So the ultimate goal of these activities is to introduce students to Python programming and also introduce them to machine learning. So I've divided this lesson into 3 different parts. The first part is going to be introduction to Raspberry Pi board. The second part is going to be interfacing sensors with Raspberry Pi. And then the third part is going to be introduction to machine learning. So the first lesson is pretty simple and straightforward. I'm going to introduce students to Raspberry Pi board. The objective of this is to have students examine different features of Raspberry Pi board. I want the students to know what should be plugged in each pin. I want students to understand how to set up pins and how to enable models. So these are very simple, straightforward activity, but I think it is fundamental and it's very important because they're going to be using Raspberry Pi in so many other activities and projects. And so it is important that they understand just the pins and how to connect stuff. After that, we're going to move on to lesson 2, which is going to take a little bit time. This is where students are going to be able to interface Raspberry Pi with the sensors and other input-output devices. The objective here is to introduce students to basics and easy Python codes so that they can familiarize themselves with different syntax and the flow of logic in a code. Also to undertake some group project based on the activities that they will be doing in this class, or sorry, in this lesson. So we are basically going to use the same sensors and input-output devices that we use in this project. So we're going to have a lot of activities involving LED lights, a lot of activities involving motion sensors, Pi camera, sound sensors, and a combination of 2 or more of these devices. Hopefully by finishing up some of these activities, students will have mastered how to program using Python. And then I have a list of projects that they'll undertake. They don't have to do all of them. I will expect students to work in groups to complete at least one of these projects. Hopefully they will have learned or mastered enough Python code to be able to finish those projects. So lesson 3, I'm going to introduce students to machine learning. So hopefully they will have mastered Python coding. And so in this lesson, we'll be using out-of-the-box models and try to apply them in different data sets. The whole objective of this activity is to enable students to master the workflow of machine learning. So first and foremost, I want students to learn different types of packages and libraries and understand when to use them. I want students to understand how to import data, how to clean up data, how to split data into train data, test data, and then how to pre-process data and to complete a task. Some of the activities that we'll be looking at are, the first one is going to be dog and cat images. I want students to be able to create a model that can distinguish the image of a dog from a cat. There's also this resource called Machine Learning Gladiator. It has a lot of out-of-the-box activities that can walk students step by step how to complete a task in machine learning. And I'm intending to use 1 or 2 of those activities just to have my students get more familiarized with machine learning. And then lastly, we'll conduct an activity whereby students will be able to distinguish a clap from a whistle and the noise within the surrounding. So hopefully this goes well with these activities. If that goes well, the students should be able to undertake a project whereby they can distinguish an image of a girl from a boy. I think that would sound very interesting and controversial at point, but I think it's a very important project that they can undertake to demonstrate their understanding of machine learning. So having gone through this project this summer, I still have some concerns going to the next school year. Of course, one of the biggest concerns is if you have virtual academic year, that's going to pose a huge challenge for so many reasons, but mainly in my class, it's going to be technology cost of materials because now students cannot share materials, and just doing virtual support can be a challenge in itself. Software is still a big concern, especially machine learning. Machine learning is pretty challenging, and I'm not very comfortable with it, and therefore it's going to be a learning process. Just based on some of the concerns I have, I think some of the possible solutions is to have a web-based Python IDE like Jupyter if we go virtual. But the other most important part is continuing this collaboration in Morgan State University, I think might help us solve some of these challenges that we have, especially the cost of materials or just virtual support in case we run into some software issues.
Okay, thank you, Mr. Dennis. So we have some of our future goals. We intend to continue working on getting the neural network to accept the test data so the neural network can predict the types of sounds, just as I explained before, to be able to distinguish between the sound of a gunshot and the sound of the fireworks and any other thing. And also we intend to develop a web application so that the videos and data from the system can be accessed. You might be asking how the cops will access these video files we've recorded. So this is how we intend to go about it. The web app to create a web application so that the videos and data from the system can be accessed. We also intend to continue working with our student mentor, Ms. Fatima, and refining programming and other skills useful for other applications, just to gain more skills for future use. And we also, as Mr. Dennis just mentioned, he intends to develop activities and projects for high school students, which might just trigger their interest for engineering. Next slide. Okay, thank you everybody for listening. Here are some of the materials we consulted to just get some more information. Thank you for listening.
Thank you.
Yeah, if you have some questions.
Thank you, everybody.